How do we tame infinity with relations? That is the journey here. We begin with free categories, where paths can multiply without bound, and we move toward quotient categories, where relations identify different paths and collapse that uncontrolled growth into something finite and understandable. Let us start with the basic geography. There are 4 objects named 1, 2, 3, and 4. At object 1, there is a loop named L. There is an arrow named X from object 1 to object 2. Then there is a triangle among objects 2, 3, and 4. Arrow A goes from 2 to 3. Arrow B goes from 3 to 4. Arrow C goes from 4 back to 2. Before looking at all possible paths, we divide the whole quiver into 3 families. The first family is called the spinners. These are the paths that stay at object 1 and never cross X. The second family is called the cyclists. These are the paths that stay entirely inside the triangle on 2, 3, and 4. The third family is called the migrants. These are the paths that begin at object 1, cross X, and then continue inside the triangle. There is also an important directional fact. No path can go backward across X. The arrow X only goes from 1 to 2. So once a path has crossed from 1 into the triangle, it cannot return to 1. That is why every possible path really does belong to one of these 3 families. Now let us study the first family, the spinners. These paths start at object 1 and never cross the bridge X. Since there is a loop L at object 1, we can go around that loop again and again forever. The number of spins is called n, so the general form is L repeated n times, where n can be 0, 1, 2, 3, and so on without end. Let us list them carefully. 0 spins means the identity path at object 1, called E1. 1 spin means L. 2 spins means L followed by L. Since we are reading paths from right to left, the rightmost L happens first, and then the left L happens second. 3 spins means L followed by L followed by L. Again, the symbol farthest to the right happens first, then the next one to its left, then the next one to its left. And this continues forever. So the loop at 1 creates an infinite family of paths all by itself. Now let us move to the second family, the cyclists. These paths start somewhere in the triangle on 2, 3, and 4, and they stay inside that triangle. Because the triangle closes back on itself, we can go around it over and over again. The number of full laps is called m. Here we must be very careful with the convention. The written path CBA must be read from right to left, so it means first travel along A, going from 2 to 3, then travel along B, going from 3 to 4, then travel along C, going from 4 back to 2. So CBA is 1 full lap starting and ending at object 2. In the same way, the written path ACB must be read from right to left, so it means first travel along B, going from 3 to 4, then travel along C, going from 4 to 2, then travel along A, going from 2 to 3. So ACB is 1 full lap starting and ending at object 3. And the written path BAC must also be read from right to left. So it means first travel along C, going from 4 to 2, then travel along A, going from 2 to 3, then travel along B, going from 3 to 4. So BAC is 1 full lap starting and ending at object 4. Now let us go through the 3 starting points one by one. If we start at object 2, the general written forms are these. First, CBA repeated m times. Read right to left, that means keep doing full laps starting at 2. Second, A followed by CBA repeated m times. Read right to left, that means first do the repeated full laps based at 2, and then take 1 extra step along A so the path ends at 3. Third, BA followed by CBA repeated m times. Read right to left, that means first do the repeated full laps based at 2, then take A, then take B so the path ends at 4. If we start at object 3, the general written forms are these. First, ACB repeated m times. Read right to left, that means repeated full laps starting at 3. Second, B followed by ACB repeated m times. Read right to left, that means first do the repeated full laps at 3, then take 1 extra step along B so the path ends at 4. Third, CB followed by ACB repeated m times. Read right to left, that means first do the repeated full laps at 3, then take B and then C so the path ends at 2. If we start at object 4, the general written forms are these. First, BAC repeated m times. Read right to left, that means repeated full laps starting at 4. Second, C followed by BAC repeated m times. Read right to left, that means first, do the repeated full laps at 4, then take one extra step along C so the path ends at 2. Third, AC followed by BAC, repeated M times. Read right to left, that means first, do the repeated full laps at 4, then take C and then A so the path ends at 3. Now let us read the example list, starting at object 2. 0 laps gives 3 possibilities. The first is E2, the identity path at object 2. The second is A, which means go from 2 to 3. The third is BA. Since paths are read right to left, that means first, A from 2 to 3, then B from 3 to 4, so BA is a path from 2 to 4. 1 lap gives CBA, ACBA, and BACBA. Read right to left, CBA means first A, then B, then C, so that is 1 full lap from 2 back to 2. Read right to left, ACBA means first A, then B, then C, then A. So that path starts at 2 and ends at 3. Read right to left, BACBA means first A, then B, then C, then A, then B. So that path starts at 2 and ends at 4. 2 laps begin with CBA, CBA. Read right to left, that means first A, then B, then C, then A, then B, then C. So that is 2 full laps starting and ending at object 2. And from here, the family continues forever. Now let us turn to the third family, the migrants. These paths begin at object 1, take some number of spins around L, cross the bridge X into the triangle, and then possibly make laps inside the triangle. This family combines the 2 infinite sources at once. The loop at 1 can be repeated many times, and the triangle laps can also be repeated many times. Again, the convention is essential. Paths are written from right to left, so the symbol farthest to the right happens first. Let us read the general forms carefully. For paths ending at object 2, the written form is CBA repeated M times, then X, then L repeated N times. Read from right to left, that means first spin around L exactly N times at object 1. Then cross X from 1 to 2. Then perform M full laps around the triangle based at object 2. So these are migrant paths from 1 to 2. For paths ending at object 3, the written form is A followed by CBA repeated M times, then X, then L repeated N times. Read from right to left, that means first do N spins on L at object 1. Then cross X to object 2. Then perform M full laps around the triangle based at object 2. Then finally take a from 2 to 3. So these are migrant paths from 1 to 3. For paths ending at object 4, the written form is BA followed by CBA repeated M times, then X, then L repeated N times. Read from right to left, that means first do N spins on L at object 1, then cross X to object 2. Then perform M full laps around the triangle based at object 2. Then take A from 2 to 3, and then B from 3 to 4. So these are migrant paths from 1 to 4. Now let us read the example list ending at object 3. 0 laps and 0 spins gives AX. Read right to left, that means first X from 1 to 2, then A from 2 to 3. So X is a path from 1 to 3. 0 laps and 1 spin gives AXL. Read right to left, that means first L, so 1 spin at object 1. Then X from 1 to 2. Then A from 2 to 3. So AXL is again a path from 1 to 3. But now it includes 1 extra spin before crossing the bridge. 1 lap and 2 spins gives a CBAXLL. Read right to left, that means first L, then L again, so 2 spins at object 1. Then X from 1 to 2. Then A from 2 to 3. Then B from 3 to 4. Then C from 4 to 2. Then A from 2 to 3. So this path starts at 1, spins twice, crosses into the triangle, goes once around the cycle, and finishes at 3. That is the key idea. In this family, 2 different infinities are being tracked at the same time. The number n counts how many times we spin at object 1. The number m counts how many times we go around the triangle. And because both can grow without bound, the migrant family is also infinite. Now we apply the relations, the collapse. Up to this point, the category has been infinitely large. Now the mathematical rules for equality begin to squeeze that infinity down. The first rule says that the written path LL is equal to the identity path at object 1. In words, 2 spins are the same as 0 spins. So the spin counter can only matter up to whether it is even or odd. That means every longer string of L's collapses to just two possibilities, either the identity path at 1 or a single L. The second rule says that the written path CBA is equal to the identity path at object 2. Remember the right-to-left convention. So CBA means first travel along A from 2 to 3, then along B from 3 to 4, then along C from 4 back to 2. In other words, one full lap based at object 2 collapses to the identity at object 2. Any path containing that segment can be shortened by replacing CBA with the identity at 2. But here comes the critical mathematical correction. This does not mean that ACB is the identity at object 3, and it does not mean that BAC is the identity at object 4. Those do not disappear completely. Instead, the laps based at 3 and 4 become idempotent. For example, the written path ACB-ACB simplifies to A followed by CBA followed by CB. Then CBA collapses to the identity at 2, so the whole thing becomes A followed by the identity at 2, followed by CB, and that reduces back to ACB. So repeating that cycle does not create anything new, but it also does not vanish into an identity. Exactly one non-identity cycle survives at object 3, and exactly one non-identity cycle survives at object 4. Now we can describe the finite quotient category, the surviving 20. Because of the relations, the infinities disappear instantly, but because the cycle ACB is not the identity at 3, and the cycle BAC is not the identity at 4, something still remains. First come the spinners. Since the spin counter can only be 0 or 1, only two spinner paths survive, the identity path at 1 and L. That gives a total of 2. Second come the surviving cyclists. Here the laps collapse, but traces remain. Starting at 2, the surviving paths are the identity path at 2, then A, then BA. Read right to left, A is the path from 2 to 3, and BA means first A and then B, so it goes from 2 to 4. Starting at 3, the surviving paths are the identity path at 3, then ACB, then B, then BACB, then CB. Read right to left, ACB is the non-identity cycle based at 3. The path B goes from 3 to 4. The path BACB means first B from 3 to 4, then C from 4 to 2, then A from 2 to 3, then B from 3 to 4, so it starts at 3 and ends at 4. The path CB means first B from 3 to 4, then C from 4 to 2, so it starts at 3 and ends at 2. Starting at 4, the surviving paths are the identity path at 4, then BAC, then C, then a circa. Read right to left, BAC is the non-identity cycle based at 4. The path C goes from 4 to 2. The path AC means first C from 4 to 2, then A from 2 to 3, so it starts at 4 and ends at 3. Altogether, the surviving cyclists contribute 12 paths. Third come the migrants. Their behavior is absorbed into the rules based at object 2, because every migrant must cross X into 2 before doing anything in the triangle. Ending at 2, the surviving migrant paths are X and XL. Read right to left, XL means first L at 1, then X into 2. Ending at 3, the survivors are AX and AXL. Read right to left, AX means first X from 1 to 2, then A from 2 to 3, and AXL means first L, then X, then A. Ending at 4, the survivors are BAX and BAXL. Read right to left, BAX means first X, then A, then B, and BAXL means first L, then X, then A, then B. These migrants contribute 6 paths. So the count is 2 plus 12 plus 6, which equals 20 finite paths. Infinity has now been brought under control. How do we know nothing has been missed? The tool we use is called a Hom-set, short for Homomorphism Set. A Hom-set asks a very precise question. What is the complete list of paths starting at one chosen object and ending at another chosen object? We say this aloud as Hom of A and B. Let us test the idea on Hom of 1 and 3. We want all paths that start at object 1 and end at object 3. Such a path must cross X, then travel along A, and it may optionally spin around L first. Now suppose we also try to include a full lap based at 3. The written path would be ACB composed with A composed with X. Because of associativity, we can regroup that as A composed with CBA composed with X. But CBA is equal to the identity path at 2. So this becomes a composed with the identity at 2 composed with X. And that simplifies to AX. So even if we insert a full lap from object 3, nothing new survives. The only survivors are a X and a XL. Read right to left, AX means first X and then A, while AXL means first L, then X, then A. So Hom of 1 and 3 consists of exactly those two paths. and nothing else. The final proof comes from arranging all the Hom-sets into a category matrix. The rows tell us where a path starts, and the columns tell us where it ends. In the first row, starting at 1, the entry ending at 1 contains the identity at 1 and L. The entry ending at 2 contains X and XL. The entry ending at 3 contains a X and a XL. The entry ending at 4 contains BAX and BAXL. So row 1 has 2 plus 2 plus 2 plus 2 plus 2, giving 8 paths. In the second row, starting at 2, the entry ending at 1 is empty, so there are 0 paths. The entry ending at 2 contains the identity at 2. The entry ending at 3 contains L. The entry ending at 4 contains BA, so row 2 has 0, plus 1 plus 1 plus 1, giving 3 paths. In the third row, starting at 3, the entry ending at 1 is empty, so again 0 paths. The entry ending at 2 contains CB, which means first B and then C. The entry ending at 3 contains the identity at 3 and ACB. The entry ending at 4 contains B and BACB. So row 3 has 0 plus 1 plus 2 plus 2, giving 5 paths. In the fourth row, starting at 4, the entry ending at 1 is empty, so 0 paths. The entry ending at 2 contains C. The entry ending at 3 contains AC, which means first C and then A. The entry ending at 4 contains the identity at 4 and B, A circa. So row 4 has 0 plus 1 plus 1 plus 2, giving 4 paths. When we add the row totals together, we get 8 plus 3 plus 5 plus 4, which equals 20. That proves the list is perfectly complete. Please consider liking, sharing, and subscribing if you would like to support the channel and continue this journey of guided mathematical exploration.